You're still functioning. You're still answering emails, still showing up, still producing. But something feels different. Work that used to feel engaging now feels mechanical. Tasks feel heavier. Even rest doesn't restore you the way it used to. You don't feel sick. You just feel depleted. That state has a name: burnout. But burnout isn't just psychological, it's biological. If burnout isn't just exhaustion, what's actually happening inside the brain? Burnout develops when stress activation becomes chronic without adequate recovery. In short bursts, stress sharpens performance, but when activation becomes persistent, the stress system shifts. The HPA axis remains engaged longer than it should. Cortisol rhythm flattens. The brain stops interpreting stress as temporary. It begins interpreting it as baseline. Research on occupational burnout consistently shows altered stress physiology patterns. Not dramatic spikes, but subtle dysregulation. Burnout is prolonged adaptation to sustain demand, but stress dysregulation is only part of it. Burnout also reshapes motivation circuits. The brain's reward system depends on dopamine signaling. When effort and reward feel aligned, motivation sustains. But chronic overexertion without perceived progress disrupts that balance. Dopamine responsiveness decreases. Tasks feel less meaningful. Engagement declines. This isn't laziness, it's reward recalibration. The brain protects itself from prolonged, unrewarded effort by reducing drive. Studies on burnout show reduced reward sensitivity in brain imaging data. The system adapts to overload by dulling incentive. But burnout doesn't just affect motivation. It affects cognition. Sustained cognitive demand strains the prefrontal cortex. This region regulates planning, decision-making, and emotional control. When stress persists, the prefrontal cortex becomes less efficient. Attention narrows, emotional reactivity increases, mental flexibility declines. This is why small problems feel larger during burnout. The regulation system is fatigued. Neuroimaging research suggests altered connectivity patterns under prolonged stress exposure. Burnout isn't imagination, it's altered neural coordination. So burnout reshapes stress systems and reward circuits. But what makes it hidden? Burnout builds gradually. At first, productivity remains high. Performance might even improve. Adrenaline compensates. But compensation is not recovery. Over time, sleep becomes less restorative. Motivation declines. Emotional resilience weakens. Yet outwardly, everything appears functional. That's the hidden phase. The biology shifts quietly before behavior collapses. And many people don't recognize it until disengagement becomes obvious. If burnout is biological adaptation, can it reverse? Yes, but not with productivity hacks. Burnout recovery requires signal change. Reduced sustained stress exposure, true psychological detachment from work, consistent sleep restoration, re-engagement with intrinsically rewarding activity. When stress rhythm stabilizes, dopamine responsiveness recalibrates, prefrontal efficiency improves, the brain regains flexibility. Burnout is not weakness, it is prolonged imbalance. An imbalance can be corrected, but not ignored. Burnout is not simply feeling tired of work, it is biological adaptation to sustained, unresolved demand. Stress rhythm shifts, reward circuits dull, cognitive regulation strains. The brain protects itself by reducing engagement. Understanding burnout biologically removes stigma. It reframes the experience, and it points toward recovery through signal stability, not force. Subscribe to Vera Human and continue understanding the biology shaping your performance, your resilience, and your long-term brain health.